The determinant of a matrix is defined as the sum of all signed elementary products of that matrix. For an n by n matrix, there will be n factorial elementary products. For a 2 by 2, 2 times 1, which is 2. For a 3 by 3, 3 times 2 times 1, which is 6. For a 4 by 4, 4 times 3 times 2 times 1, which is 24. Another important thing to know is that there will be an equal amount of positive and negative elementary products. For this 2 by 2, find all elementary products. Here they are. 1 positive, 1 negative for a total of 2, n factorial 2 factorial, which is 2. Here are all the elementary products for this matrix here. It's a 3 by 3. We expect 6. There are 6. 3 positive and 3 negative. 1, 2, 3 positive, 1, 2, 3 negative. So very straightforward. Find the elementary products, do it however you want, add them all together. Now it really becomes a matter of what is the best way to do this. And in my opinion, rather than doing it the long way, which I described previously, this is the method I find to be the quickest and best with the least amount of possibility for error. And what it involves is starting with the top left corner and then making crisscrossing patterns across the matrix. For a 2 by 2, this is really easy since there are only 2 entries. Start with the top left and go diagonally down to the right. This will be the positive entry. Starting with the right corner now and going down to the left, these will be the negative entries. Multiply them together and then add them up. And this is the formula for the determinant of that matrix. For a 3 by 3, it becomes a little bit different. Still the same idea, but with an extra step. Start with the same idea. Top left, go down to the right. This is a positive entry. All of the ones going from left to right are going to be positive entries. All of the ones going from right to left will be negative. So for the first row, this is very simple. There are 3 entries. A11, A22, A33. Fine. But going into the next one, A12, A23, and then there are only 2. But since it's a 3 by 3, there need to be 3 multiplications per entry. If it was a 4 by 4, then there would need to be 4. For the 2 by 2, there was 2. For a 5 by 5, there would need to be 5. And so on. So now what I need to do is take the first row and then add it on to the end of the matrix over here. Now when I do this row, there will be 3. So I do the row. Now there are 3 entries. I write those down. This is another positive entry. And then the final row, A13. So go down, and again I have the same problem where I've only got 2 entries, but it's remedied by the exact same sort of thing. Take the second row now, or second column I should say, and then add it on to the end. Continuing the diagonal, now there are 3, and I'm done. And a question might be, how do I know when to stop? Well, the easy way to remember is you take the total number of entries. There are going to be n factorial, so there will be 6. Half of those are going to be positive, half of those are going to be negative. So I need 3 positives. Now that I've done this 3 times, with this, this, and this, now I stop. Now I can leave these columns that have been added here because I'm going to use them again for the negative entries. Same thing as a 2 by 2. Start with the top right corner, make the diagonal going down to the left, write those entries down, go over 1, down to the left, write those entries down, over 1, down to the left, write those entries down as well. Add them all together. This will be the formula for the determinant of a 3 by 3. And I can use the same technique for a matrix of any size. If I wanted to go 4 by 4, I would just scale it up even more. Or for a 5 by 5, then I have to scale it up again. but this principle will work for a matrix of any size.